First, I'd like to welcome everyone to the first virtual HBRC meeting. Really appreciate your being here to make this a success. We do not want this club to die in the middle of the virus epidemic. I'll first point out that this is an experiment, and hopefully we will continue to do this every month if this is successful. And I want to encourage everyone to please give feedback as to what you liked and what could be improved about this online meeting. You can either do it personally to any of the officers or myself, or you can leave comments in the news group so that we can get some feedback and make this better if it needs to be. Also, thank you to everyone who has been posting their robots and pictures in the news group. It's great to see everybody working on robots still. I know there's nothing else to be doing, right, while you're stuck at home. So keep building those robots, and we really appreciate you posting your projects. Also, this meeting will be recorded as the usual meetings are, and eventually will be up on our YouTube channel. So if you want to rewatch, or if you missed something, and for the people that couldn't attend, you'll be able to see it on YouTube. Now, we're going to try to keep to the original format as much as we can. We're going to start off with some robot and club related news, then we're going to move on to the show and tell, and then our presentation today is going to be by Wayne Gramlich. So he'll talk on that. But the random access afterwards might get a bit chaotic. I don't know if we'll leave this meeting open for people to turn on their microphones, and we'll see how pandemonium it gets. But like I said, this is all an experiment. So right now, we've initially muted everyone, and Arthur is in control of pretty much everything, the chat, the voice, and video spotlighting. So I hope everyone here knows how to get to the chat window in Zoom. And that's where we're going to pipe up for those who have robots to show. And also you can ask questions during Wayne's talk, during the Q&A. And then Arthur will read those out loud, and Wayne will answer them. And to make it easier, we're just going to use the text chat. One note is that Zoom has been getting some attention for attracting malicious meeting crashers. And if that happens here, we can easily disable the chat, and we'll resort to the raise your hand feature. So just in case that happens, I hope you all can find the raise your hand feature if chat happens to need to get shut down. So let's see, yeah. Next we'll start. If there's anything I missed as far as procedure, I think that's pretty much it. So next, if you have any robot related news or events, please type the word news in the chat channel, and Arthur is going to enable chat right now. And anyone who has news, please pipe up. I'm first going to hand it over to Dan Tuschler, who has some Treasury update. So take it away, Dan.
Okay, can you hear me?
Yes.
Can you hear me okay? Okay, great. So this will just be very brief. As of 2 meetings ago, February 26th, we had 77 paid members, and including family members, that brings us up to 93 members. We've had nobody sign up in the last 2 months, and hey, that's not surprising because, you know, it's been a little bit weird the last couple of months. But I think it's still a good idea. So if you haven't signed up, I encourage you to. It's, of course, always optional. The benefit is that you can vote at the end of the year. You can get a badge if we get back to having physical meetings. So please, if you think it's a good idea to support the club, and I certainly do, I encourage you to sign up. Otherwise, things are shipshape, and that's it. Any questions? Okay.
All right. Next, I'm going to hand it over to Camp Peavy, who wants to mention some club news. So if we could spotlight Camp.
Hello, can you hear me?
Yes, we hear you.
We hear you.
All right, we've got another virtual SIG for May 20, the penultimate Wednesday. And I'd like to plug the June virtual challenge. That's the month after next, phase 2, unless Wayne wants to do something different. The thought is that we do what we did in March, phase 1, namely through the month, post images, videos, and stories about what you're working on. You are working on something, right? And everybody's on the mailing list, right? During the month of June, and then we can have one big virtual show and tell on June the 24th. Let me know what you think. Thank you.
Sounds good.
All right. Let me quickly check the chat channel if anybody else had mentioned that they need to mention club news. It doesn't look like anybody said anything. In case we don't accidentally mute your microphone, please do so, because you accidentally grab the video focus whenever there's a little bit of noise. I'll give a few seconds to anybody if they have any news. Please say so in the chat channel. Okay, does anybody want to talk about what happened at the SIG meeting? Any results from that or anything interesting?
I'll say something.
Go ahead.
That is that Alan, Dr. Bott gave his demonstration of the virtual ubiquity robot, and Greg Maxwell talked about the subterranean challenge. I did my never-ending ROS bot navigation demo, which I'll try again this evening. And it was a good time. Good time was had by all. And good experiment with the Zoom tele.
All right. So let's move on to the show and tell. So I'm hoping people have brought some robots to show. I know I did. As you see in the chat channel, I just texted robot screen, which means I'm going to need to screen share, and I have a robot to share. So if everybody else, Camp included, if you're going to be showing off a robot, please text and let us know in the chat channel, and then we can give you the spotlight. So Camp, are you ready to go first?
Yes.
All right. Well, since you have the camera already, we'll keep it on you.
All right. Well, let me walk to the back room here. I have a new table bot doing phase 1. This is actually a commissioned work. I've named it Whiskers. This is the Arduino, and he's got bump and he's got drop sensors. And let's give him a go and see how he does. No hands. Seems to be stuck in the corner. Come on, Whiskers. You can do it. Oh, there he goes. Kind of exciting, huh? All right. There you go. Phase 1. That's Whiskers. Thank you very much. Yeah, thank you. Thank you. To get one quick setup here. And this is, everybody knows Turtle One. There he is. And I'll have him do the Floorbot challenge. Bear with me 10 seconds. Actually, if somebody else wants to go ahead while I set this up, that would be fine.
Okay, it looks like Carl Picken has a robot to show called K8. So Arthur, if you could highlight Carl's video, we'll set him up next.
Okay, can people hear me? Am I live?
Yes, you're live.
Okay, all right. So this is K8. So first of all, it's really great to be here. Actually, I won't blabber on for too long, but I'm not from your area. I'm from up in Alberta. So I was thinking of setting up an Alberta chapter of your club, but it seems you guys have come to me instead. So this is K8 or Kate. Where is she? Hold on. Terrible. For some reason the camera's inverted. She's based on a fairly standard the Devastator chassis. For some reason the angling is really weird. Completely loaded with sensors. We've got 3 ultrasonics, and we've got the TF Mini LiDAR. We've got the rotating Nito LiDAR. Quite a bit of customized metalwork and some laser cut parts here as well. For some reason, why is this working the wrong way? Never mind. She's based on, I'm using it currently to learn ROS, but the demonstration I'm about to give is not using ROS. I've got a little switch there that's somewhere here that enables me to operate with 2 different images. So this is not based on ROS, but it is based on Google Assistant. So I can do the usual Google Assistant stuff. So, okay, Google, what time is it in Sunnyvale?
The time in Sunnyvale, California, USA is 7:17 p.m. on Wednesday.
And then obviously all of the robot commands are controlled by voice. So, okay, Google, look around. Okay, I'm going to first put her onto the floor. So just hold on a minute. I'll put her down. Okay, so that's reasonably good. Okay, so she's got a little gyro inside, a GY521. Okay, Google, left 90. So that's pretty much exactly 90 degrees. And then obviously odometry for distance. So, okay, Google, do a square. Okay, Google, clockwise. Okay, Google, disco time. Okay, Google, impersonate a Dalek.
Exterminate! 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 Exterminate!
Okay, Google, impersonate Knight Rider. I'll hand over to somebody else there. There's a lot of other cool stuff she'll do. I've got her playing chess and a few other few other little gimmicks, but I won't hog the time.
There was one question here for you, Carl, asking, are you fusing the gyro with the odometer to do the 90-degree turns?
Yes, yes, I am. Well, in a very bizarre way. I'm not using anything.
Well, in a very bizarre way. I'm not using anything.
I've got a horrible echo actually, so apologies if I can't speak properly. It's what I've basically got is I've got a PID loop working on the odometry, and then the PID loop is controlled by a proportional on the gyro. So it's kind of fused together, but not with any sort of sophisticated Kalman filter or anything. It's a sort of a kludge of a P loop and a PID loop sort of thing, but it seems to work pretty well. I get it within, I can do sort of like about 20 or 30 squares, and you know, sort of a little square demonstration. If I repeat that 30 times, I'm still pretty much on track. It might drift by maybe a degree over about 20 circuits.
All right, I'm sure there's going to be lots more questions, so keep your eye on the news group, Carl, and I'm sure people will be asking you more questions there. Okay, next we have Fergs. So Arthur, let's pin the video on Fergs for his robot.
Is this working then?
There you are.
Okay. Whoa. Doesn't change on my screen, I guess. Oh, there we go. Okay, cool. So yeah, this is actually a fairly old robot. I actually laser cut this frame back when I worked at Willow Garage. This is my Robo Magellan robot. Recently has been getting some upgrades and actually getting some software loaded on board. So internally, it's got 4 drive motors. These are actually just the Palalu, like 37mm drive motors with encoders on them. That's all wired up to, get that here, my Robotics board, which is basically an STM32F4 doing Ethernet to motor conversion. It's also got an IMU on it. That's pretty much all I'm using off of there. I am also routing the GPS module through there just to do serial Ethernet. And then I've got an extra IMU up here on the top that's a little bit better one. And then when I first built this, I actually built it with a scanning laser that was panning up and down. But I've now replaced that with an Intel RealSense camera, one of the 90-degree field of view ones. So I've been working on the software quite a bit for this over the past couple of weeks. It's actually doing using the ROS package called Robot Localization to basically fuse the GPS, the IMU, and the wheel odometry to figure out where it is in the real world. And that's working pretty well right now, other than the fact that the GPS is actually pretty terrible. I just got an external antenna for it, so that'll be one of the things I'm going to be putting on it. And I'm waiting for them to arrive. I ordered some RTK GPS modules. So I'm going to be setting up an RTK base station here on the farm up in New Hampshire, and then should hopefully have a lot better localization out of that. But yeah, so first time I've gotten to bring a robot to a meeting in, I don't know, 5 years or something probably.
All right, thank you. Any questions for anybody?
Does it have a name I see popped up down there? No, it doesn't. It's just my Robo Magellan robot. Even the repo is on my GitHub is just Robo Magellan, and so everything, all the code's in there. And I've actually been posting. I sort of revived my robotics blog a couple weeks ago for National Robotics Week, and so that's now up at robotandchisel.com. I'll put a link to that to the mailing list. And then plastic around the GPS. Yeah, basically it's just a thing to enclose it. And so it's just kind of protecting around the edges there, basically keep it from shorting out against the frame. I'm actually going to be putting an external antenna on it now. And so that whole box is going to end up moving down inside of it. And yeah, let's see, I see somebody asked, Am I Ferguson at cs.albany.edu? Yes, I am, but that email address no longer works. I haven't had access to my Albany email for, since I started at Willow Garage. So that goes back quite a ways. And obviously Willow Garage was almost a decade ago. So, yep. Yeah, Camp at pretty much every meeting points out the Nino drivers, the software, so. I'm calling in from New Hampshire. I lived in the Bay Area for a number of years. I moved out of the Bay Area about 2.5 years ago at the end of 2017. And I now have a 20-acre farm in New Hampshire where I still work for a Bay Area company, but I'm only out there every so often. And with coronavirus, I have no idea when my next trip to the Bay Area will actually be. Cool. Thanks, Chris.
All right. If there's no more questions, we're going to move on to Michael Wimble. We'll start by spotlighting the video on you, and I noticed that you also need to do a screen share. So Arthur will start off with giving Michael Wimble the camera, and then we'll be ready to share his screen when he lets us know.
I'm ready to swap over here.
I'm sorry, Michael Wimble.
The other Mike Wimble.
The other Michael, yeah. All right, you have the camera.
Okay, let's see.
And you should be able to share your screen. Down below, there's a start share screen button. There we go.
Yeah, we see your screen now.
All right, do you see that picture?
Yep.
All right, so I've been rebuilding Nady. If some of you may remember it. This was taken a day or two ago of the rebuild. This is all being built out of cast acrylic. So just quickly, that big mess of wires you see, the heavy cables, that's a bunch of HDMI/USB connectors. There are 5 onboard computers, about to be 6 onboard computers. So there's 6 sockets back there, so I can plug in if I ever need to run the real video from those things. The center box that has paper on the acrylic, that houses a 36 volt, 10 amp hour battery, lots of power. And the silver boxes on it there are a bunch of power supplies and the RoboClaw motor controller and a voltage snubber for the motors to prevent the supplies from failing. On that back panel with the video connectors is also a power monitor, a nice little thing that shows me the total power, the temperature of the battery, current, voltage, things like that. In the center where you see all those red and black things, those are Anderson power pole connectors. There's 2 distribution panels, one for 5 volts, one for 12 volts. And just to the right of them, where you see that white square is the TP-Link thing that does ad hoc / local networking. And behind it are the 5 computers that you can't really see in this picture. And to the upper right, you see just hanging loosely 3 of the stereo cameras. So there's a pair of D435 depth cameras, RGB and depth cameras. And just to the left of them, there's a T265 odometry camera. The motors, the wheels there are 8-inch wheels powered by Super Droid motors. I burned out a number of Pololo motors and get really mad at them because how easily they burn out. So I bought a motor with a little more capability. There's also current sensors attached to those motors, and there's a safety node that checks to make sure the motors aren't over currenting. And there's lots more to come on this thing here. So just a snapshot of where I am on this thing. And let me turn off the screen sharing if I know how.
There's a question for you here about why the 5 computers? What do you need the 5 for?
Okay, the D40 435 cameras require a lot of USB 3 bandwidth. So there's 4 upboards in there. Each of them is an Intel computer. It runs 2-point-something gigahertz quad core, 4 gigabytes of memory. They're running Ubuntu. So 2 of those pretty much saturate the I/O bandwidth from those D435s. They generate a lot of USB 3 output when you're running all the messages I'm running on them. So 2 of them for the 2 depth cameras. One of them is running the T265 odometry camera, which I have to say is a fairly nice piece of technology. I'm using optical odometry, which is informed by my wheel odometry, but the optical odometry is pretty much dead on. And the wheel odometry just helps it not get lost in the world as things move around. So the thing that's one of the computers that's running the 265 is also running the joystick control. It has a lot of extra headroom, which I'm not using yet. The 4th upboard is running the main everything. So it's doing the smarts, but not the SLAM algorithm. The SLAM algorithm is running on a TX2, which is not shown in this picture. And I've played around with G mapping and cartographer, which I finally got working and works fairly well. It's fairly compute intensive. And once I've built a map, I just use it for localization. But I'm going to experiment with other SLAM algorithms as well. The last computer is a Jetson Nano, and it's going to be running most of the vision AI on it. So it's going to do a lot of object recognition on this thing. So the golden task for this thing is to go to the refrigerator, open it up, grab a can of soda out of the thing, and that's what this model robot is all working toward. Maybe toward the end of the year, we'll get that. Let's see. Have I measured power consumption? Yeah, surprisingly, I haven't turned on the TX2 in this model right here. But with the other 5 computers running, it's only running so far about 25 watts on this thing. So a lot of power headroom. These things, each one of these power supplies, there's a 10 amp supply for the motor, a 10 amp supply for 12 volt, and a 10 amp supply for 5 volts on there. And I can add more on this thing. It should be closer to 100 watt once this thing is all running and doing serious computing. Nothing else? If so, I'm done.
All right, thank you very much. I'm curious how people are doing all this cool green screen effect. So I'll ask people questions about that later. Next up, let's see, we have Ralph Hips has a robot to show. So let's highlight Ralph and see what he has.
Can you hear me?
Yep, we hear you.
Okay, fantastic. So this will be quick, I think. It's just showing off Marvin here. The big change is as you know, I moved the arm up on top of the chassis. So I had to recalibrate the arm to be able to pick stuff up from down on the ground. And if everything works okay, I'll pick up this rock and drop it in the bucket. This rock is an ounce rock. It's the biggest I can pick up fairly reliably these days. Most of the time, that's about 1.33 pounds. So anyway, there you go. And that's pretty much it. So I've got them recalibrated for operation, you know, up on the chassis now. So very happy about that. And that's about where we're at on that. You guys seen the video okay? Yeah. I'm out in the garage, so my Wi-Fi is not real good.
How many pounds can that arm pick up?
Sorry?
How many pounds can that arm lift?
That is a great question. My biggest problem right now is getting a hold of stuff, getting the fingers around the rock. This rock is 0.58 kilograms, or about 1.3 pounds. Most of the time it can lift this, usually. And right now that's the biggest rock in my collection over here that I can pick up, just physically get a hold of. The arm doesn't seem to have any problem with this amount of weight. So I think, from my calculations from the torque, I could pick up a 2 pound or 1 kilogram rock, 2.2 pounds, at a distance of up to 30 inches. And, you know, the servos aren't even getting hot. I mean, it's like not even straining, it doesn't seem like. So one thing I'd like to point out is I'm using the demand peripherals power distribution board here. You guys may be familiar with demand peripherals. And that board's really great from a guy in the club. And the rest of it's an Arduino Uno and a couple DC to DCs. So, you know, pretty straightforward stuff. So there you go. That's pretty much it. Yeah, very good. And when can I buy one? There you go, from Mike. Yeah, I don't know. I've probably got, right now, I've got at least $1,000 in parts into this thing. So, you know, if you want to pony up, we might be able to work something out. Yeah, there you go, Ness, 20 bucks. There you go. Well, okay, down payment. The demand peripheral stuff is amazing, but very happy with it. Yeah, it's really good. There's a smaller one I need to solder together from him that I'm looking forward to using too. But that's good stuff. Really like it a lot. Yep. All right, very good. Well, that's it for me. I just wanted to show that real quick.
All right. Thank you, Ralph. Next up, we have George Taylor. And I will be asking you about that robot arm. So let's highlight George Taylor.
Oh.
See, am I there yet?
There you are.
Hey.
All right, let's see. I guess I'm not seeing me in the thing. Okay, I saw here a while back there were any number of comments out regarding grippers for used to pick up things. So I decided, since I needed a new controller for a little 4x4-inch CNC table that I have, that I needed something to try as a first cut. So I decided to cut out a couple of arms, and I decided to base them on what a crab. I figured if crabs can pick up stuff, maybe we can build a robot that can do that. So these arms, or claws, I guess you'd call them, each side were cut on my CNC. And interesting phenomena, to get the tips to come together properly, you of course have to set the gear off a tooth. And you notice that this is all one solid piece. I have, fortunately I have the Bobcat software, and allows you to do things like this. This is a very simple problem for that. So now I have an Arduino mounted down here, and then that's driving the servo on the back. And all we have to do here is to find the end of my cable, plug in the Arduino, and then I'm using just a standard little supply for powering your cell phone or whatever, recharging your cell phone. I find these are very nice to do to power your Arduinos. And we'll turn it on. Of course, we would probably want to mount it more like this. I realize this is a very simplistic demo for you fellows that are building the real complex ones, but I thought this would be fun, and it was. So thank you.
All right, really cool. Thank you very much. Let's see, up next, let me scroll down. Scroll down, it looks like Alan. Alan has something to show. So let's spotlight Alan.
Hello, can you hear me?
We can hear you.
Okay, well, I have hopefully an on-screen I'll share in a minute. Just wanted to talk about what I'm running. So this is my instant TurtleBot conversion on a Nito. So this just goes back in with Velcro and connects up to the USB. And then this is a Raspberry Pi B with a joystick controller and the version 1 camera. And in the intro to ROS code, if you go down deep in the BV80 node include, you'll see there is another launch file that's launch with cam, which then calls upon Ubiquiti image, the RaspiCam node, and the fiducial stack to locate fiducials. And it was all working 2 years ago. Right now I'm trying to get it up again. And the fiducials are, the markers are fighting with the 2D nav goals. Eventually I'll get that working. So let me see if I can share my screen. This guy.
Do you need to share your screen? Oh, there you go.
You guys seeing it?
Yep.
Okay, so so this is ROS by example, Patrick Goebel's robotics simulation. So that's working. And the robot always turns clockwise. Oops, I had a little trouble with the obstacle there. Let's see if we can figure it out. Oh, I think my obstacles are inflated a little too much. So it's struggling. So I'm going to reset that. Oh, it got there. But I also have I also have voice commands. Rotate right 90 degrees. Rotate right 90 degrees. Oops. Rotate right 90 degrees. I'm going to give it a little help. Rotate right 15 degrees. Forward 1 meter. Oops. Forward 1 meter. Great, crazy robot. I guess those the local coast map is a little too big. Forward 2 meters.
Oh darn, there has been an internal server error.
Okay, but it did it anyway. Let's see if it goes off the map. Oh, it's lost now. So now I'm actually controlling it by buttons. Forward 1.5 meters.
Oh darn, there has been an internal server error.
Yeah, I think it's off the map now, so that's why it's having some difficulty. Let's see if this helps. Yeah, once it's off the map. Forward 1 meter. Okay. Forward.
Failed to find a valid plan, even after executing recovery behaviors.
So actually, that's my voice navigator. I think I'll leave it there. So thanks. If there are any questions, I will unshare. Oh, am I unshared? Okay.
I have a quick question. You mentioned a joystick controller for the Raspberry Pi. I need one of those. Could you talk more about that?
Yeah, it's this is just a Logitech. So that's one of the gosh, if you get the joystick teleop node, which is standard ROS in both kinetic and melodic, they have a Logitech setup for it. And what you have to do is figure out what keys you want to be to map to command velocity. So I have in this room, I have one for simulation. I have one for my BotVac. I have another one for my Magni robot, and they're always getting mixed up. So I have them labeled M for Magni and BV for BotVac, and I'm always grabbing the wrong one and cursing a lot. But it's relatively simple. The dongle goes into the USB port on the Raspberry Pi. Did I answer the question?
Yeah, was it Bluetooth or IR? How does it connect?
I think it's not Bluetooth and it's not Wi-Fi. It's its own deal. Now,
yeah, but Bluetooth even works as well.
Yeah, Bluetooth works. The controller he's using, the Logitech F710, is it has its own wireless USB dongle that you plug into the Pi, and that just works.
Yeah, it's we've been using that prior to the Raspberry Pi 3 when built-in Wi-Fi came in. On the Raspberry 2, we were using a plug-in Wi-Fi, and they were never quite as reliable as the Pi. The other thing that's neat, you can get on Amazon now a set of 5 heat sinks for the $7. You get 5 sets of heat sinks for the 3 or the 4. Even has an extra one for this little copper flat one on the other side for, I think that's the communications chip. I'm not exactly sure what chip is what, but $7, 2 days, you can heat protect all your Raspberry Pis.
All right, thank you very much. Let's see, scrolling down, I think next is Mark has something to show. DroidBot progress. So let's spotlight Mark.
Go unmute. Okay, testing, yeah. By the way, I'm here at Maker Faire, as you can see. Hope that thing doesn't shoot at me. This is DroidBot, and I'm not going to run it around on the floor, but I was inspired by Ralph's fine demo that he did a little while back, Ralph Knock. And this is it's a little OLED display, and the OLED display is being driven by a small motor controller. Oh, great. I got to watch out for that. It's being driven by that ESP32 board that I'm always harping about, that I have on Mark Toys. But the key thing about this is I put the Raspberry Pi 4 on there with the February Ubiquity image. So that's been upgraded. And then it has been able to make maps and move around in my living room. Thing is, I have to set up and tear down my barriers. So I took a nice picture of the living room with the barriers in place. So that way, when I go back to use the map, the barriers are in the right place. Then one small point I had, which a bunch of folks here are already going to know, but this thing, it has the nav stack on it for the LiDAR. This is the, oh, that looks pretty cool. Anyway, this is the time vortex cone printed on 3D printing on top of the Nito LiDAR. And it runs the standard LiDAR package. And then it runs way down below. Once you get the nav stack running, it's run Ferg's famous and wonderful move base. And I can control it with either the RViz thing or also a Python script that can send to the ActionLib server on MoveBase and therefore control it from goal to goal. So anyway, I'm hoping to get it to wander around the house. Right now, it just wanders around in a pretty simple pattern and I put in a table. But that's pretty much it. And the other thing I wanted to show people here is completely unrelated, but I found it super useful for cameras. And that is you get yourself some of these little cheapo lasers on, and you put it on a protractor. And this has saved me endless time in looking at the camera field of view and so forth by just lining up one side to the other side with the dot on the ceilings. And then you can just say, oh, okay, well, this is 85 degrees, or oh, this is 62 degrees, or whatever. Anyway, super easy, super handy for those who worry about camera angle from time to time. That's it. Let's see. Yeah, there's a hole in my head. Actually, I see right through my eyes. That's way cool. And since the brain material is pretty much atrophied out of there, that makes sense. All right. Oh, mount RPI vertical and no problem with heat. Oh, it has a fan. You can buy a little kit with a fan on it that works really well for the Pi 4. I guess I'm not on video, but you can get back to me. I'll show you the link for that. So this one has an actual fan on the Pi 4, and therefore there's no heat problem. Okay. I'm not sure if there's anybody else there. Tell us after. That's it. Yeah.
All right. Thank you very much. I'm going to go next, and then we'll finish up with camp. If there's any other robots, please pipe up in the chat channel. I'm going to share my screen really quickly. Can everybody see my screen?
We see the Homebrew Robotics Club Google list.
Perfect. Yeah, I just wanted to point out two of the projects that I'm working on. You can find them on the news group. It's the My First Robot group and My Next Robot group. And I'll show you what those robots are. The My First Robot group came out of when we did a survey. We had a lot of new people that didn't really know how to get started. And so this is the hello world of a really simple robot. And then there were other people that wanted something a little bit more complex. So we've started a project. I'm working at the moment with John Erickson and John Carlini. And basically we took My First Robot, added some steroids and put bigger motors. The plan for this bigger robot is to put a basket on it and send it to the Safeway so it can go get your groceries for you. We just got it moving, so if you can see this video, this is just a short video clip of it moving. So it's a really simple Raspberry Pi talking to an Arduino, talking to a simple motor controller, controlling the the wheels. So next phase is we're going to put an arm on it so we can grab things off the shelf at Safeway. So I'm going to stop sharing. And you see the video now? I see Mark and not myself, so let me try to pin the video on me.
Should be set on
there we
you
go.
now.
Okay, I'm just gonna, I have a short USB cable on my webcam and the lighting is really bad. This is the MottBot, really simple robot. It does the table challenge and we'll do the line challenge in the maze. That's my first robot. Taking the same thing, putting it on tractor chassis. And you can see it just, sorry for the lighting, it's just an Arduino Nano, motor controller, and motors. Very simple. The bigger robot, again, apologize for the lighting and the fact that I can't move my camera very far. This is the bigger robot that you just saw moving. That's pretty much it. If you want to join in the project, if you want to build a robot that can go to Safeway and get your groceries for you, let me know or post in that news group. And if you want to build your first easy robot, let me know and we'll get you the parts and set up a online time when we can do a tutorial. Let's give it back to Camp because I think Camp had another demo to do. Camp? Camp, you seem to be muted.
I did the TableBot phase 1. Now I shall attempt to do FloorBot phase 1. Here you have the ever popular Turtle 1. I'm just hard. Let's see if we can't make it from one end of the room to the other and back.
That was it?
That computer and more bandwidth. So we're at one end of the room. The robot should turn around and go to the other end of the room. He should be at the starting point, and you'll see there goes the move baseline now.
Hey, Camp, real quick, did you dial in also on the phone? Your audio is really broken up. Yeah, we're having problems with your audio, Camp.
me unshare this.
Yeah, we're having problems with your audio, Cam.
Yeah, there you see the robot moving now. And that's it, I'm done. Oh, I'm gonna stop share. You see it go to the other end of the room and it'll hit that point and then go back to the other point and basically go back and forth from one end of the room to the other, which is Floorbot Challenge Phase 1. Thank you very much.
Chris, you're muted.
Let him know he's on. So if we could put the video spotlight on Karen Dan. Let's see. Let me see if I can do this. I'm seeing Arthur Waite has the video.
I'm looking
focused,
for
but I'm gonna
the
give it to
yeah.
Karen.
Takes me a minute to find the person in the among the 40 of us. So I think we've got it.
Okay, yeah, I know. There he is. Unfortunately, Dan, we cannot hear you if you can hear us. Maybe you don't have a microphone. So you can tell us what you're doing in the chat channel. Yeah, I'm gonna try to patch you through the cell phone. It's, like I said, this is all an experiment, so let's give it a try. Go ahead. Yeah, I'll just relay what Dan says to me. I'll be the middleman. Okay, you go ahead and talk about what you're showing, and I'm going to relay it to the rest of the people. This is a new quasi-direct drive from MJ Bot. 12.5 Newton meters. That's a lot of torque. Maximum. Continuous, we'll do 2.5 to 5 Newton meters of torque. Comes with open source code. Yeah, mjbots.com for details. This is the new motors that are going to go into Karen, formerly known as Watson. Oh, that's what is being used in the mini cheetahs. A mini cheetah, not the mini cheetah. Dan, do you have, is Karen there that you could show on video? Yeah, we can see Karen, but it's heavily backlit. All right, and how soon are we going to have Karen walking into a meeting? Okay, you heard it, folks. As soon as the coronavirus is over, Karen will walk into a meeting, even though I'm sure she's immune. All right, thank you very much. All right, it's a little after 8 o'clock. So let's take a 3-minute bathroom break for everybody. And we'll be back in 3 to 5 minutes. And then Wayne, you can start your main talk. Thank you very much for everybody who showed a robot. This is a lot more than I expected for our first video meeting. Quick question, MJ Bots, what part number? Oh, we have one more robot to show, Dara.
Can everyone hear me?
Yes, we can hear you.
So I wanted to show this robot. Wait, hold on. I think
you're on your point cloud as your webcam.
Shit. Hold on. Yeah, here we go. Can you everyone see me now?
Yeah, it works now.
Yes.
Okay. So there's this little tiny telepresence robot that I built. It's the whole point of this is like I was actually able to, you know, have a remote person drive this around. I could actually probably even fire this up in a little bit if people want to try it. But the idea is, you know, you can just drive this around a room and, you know, just literally talk to people. And I built actually 10 of these robots. And I try to see if I can find video of the action here. So let's see if I can share my screen. Oh, you don't have screen sharing enabled.
Give it another try. Just enabled it for you.
There we go. Okay. Yeah, so this is like an example of what I was doing last week with these robots. I actually had a robot soccer match with a bunch of friends, and this actually, you know, it was kind of cool. So like this is all WebRTC. I basically tested the limits of WebRTC out of my Comcast connection, but you know, it kind of worked. Yeah, so the other cool thing about this bot is it's made with less than $100-something in parts, and I have the repo for all the assembly here. So if you go to this repo, you should be able to see everything on there about how to build this robot. It's pretty much all 3D printed. It's got a ESP32 on board that drives the motors via a DRV8833. The phone speaks to the ESP32 using Bluetooth, and I've used the web Bluetooth API to talk to it. So it's actually all running from a web page. So the web page does the video call over WebRTC. It also controls the motors over web Bluetooth. And I'll do a little better right up here, but you can charge it over USB. You can also charge it wirelessly by putting the robot on top of a QR charger or QI charger, or you can actually just drive right onto a charger using the treads and it'll just charge itself. So that's kind of cool. And there's plenty of extra ports on this ESP for expansion. It's based off a used Google Pixel 1, so that costs you about $65 on eBay. Everything else should be under another 60, 65 bucks. So 120, 130 bucks total to build this. Yeah, that's that. Let me see if I can fire up this bot, and maybe someone can try to join in, although it only supports one person at a time. The other, I'm actually in the middle of moving apartments, so all of my other 9 bots are in the other apartment right now. Okay, so let's see here. So I may need like one volunteer if anyone wants to try to join this. So I'm going to post it in the chat. So just so one person claim access to this, and the first person who gets into it should be able to use it. And please use Google Chrome on your desktop. I haven't found anything else that works with this.
Any takers? Has anybody taken it yet? The control?
Yeah, I can talk to you here. Are you able to see around? Yes. Yeah. So that's telepresence. I'm actually not able to see you, but I might need to do some either bug fixing or it's possibly your video feed. So if you want to share your screen into the chat, you could try to do that.
So this is Osmond. Looks like I've taken control of your robot, but I can't share my screen. I don't have permission to share the screen.
Oh, okay.
Yeah, Arthur, could you give Dave C?
Osmond
who was it?
Osmond has access. You can share your screen, Osmond.
Again. All right. So it looks like I'm driving my robot around somebody else's apartment.
Oh, cool.
There's a slight lag, but overall it works pretty well. It's pretty
Yeah, I think the lag will be lower if. I'm not sure why the lag's so high because I didn't have that high lag, but it's possibly because you're also on a Zoom call. I'm in the middle of moving here, so excuse the mess, but you can feel free to drive around.
All right, I'll keep exploring.
Look for toilet paper, Osmond.
Yes, or hand sanitizer, either one.
So actually, one of the interesting things about this is your camera is actually in the right of the robot, on the right side of the robot, which something I can't really change with a phone. I think the experience is definitely much smoother if you're not also on a Zoom call at the same time, because I think they're both trying to do some P2P magic.
All right, I will release control and let someone else have some fun.
Cool. Yeah, so if you want to release control, all you need to do is just close the browser. Yeah, so
I'm out. Very cool.
All right. Any more questions for Dira?
Yep. If anyone wants to build some of these and have like a party, like I did soccer last week, we could definitely do lots more robot parties. Once I move into my new apartment, I can probably just get all 10 robots in one room, and we could try that next time as well.
What's the connection between the phone and the rest of the robot? Like, how does that connection work?
Yeah, so the phone talks to the motor controllers via the ESP32, so that's Bluetooth. It could also be Wi-Fi if I wanted it to be Wi-Fi, but it's Bluetooth right now.
Thank you.
All right, cool, and thank you. Now let's take a 3 to 5 minute break, and then Wayne, get ready to take it away for the main talk. All right, Wayne, whenever you're ready. I think everyone's had time to get drinks and bathroom breaks.
Okay. Let's see. The way this is working is I am running a virtual box image, and that way I don't have to keep switching between displays whenever I throw up a different thing. So basically, you're getting a visual image into a desktop, but without me taking up the entire screen. Okay, that's kind of the plan here. Okay. And all this is just a web document, and I'm just going to scroll through it. The URL is right here. You can see it. That URL will be presented again at the bottom, so you don't have to take notes or anything. You just, if you want to go see this talk, go ahead. Okay. The plan here is Arthur's pretty much going to mute everybody during the talk, although we've been doing pretty well with people doing mic control, so we might be able to relax that a little, but we'll see how that goes. Use chat for questions, okay, and Arthur, who's our Zoom moderator, will at the end of each slide, I'll ask him if there's any questions, and then he can read them off to me, because I cannot read them. It's a kind of a flaw with Zoom. And if there's, he might activate the microphone if there are any follow-on questions from that person, if I didn't do a good job of answering. So with that, I'm going to get started on the talk. Do a very brief HBR history. This is somewhat for some, I'm expecting some people have never been here before because they're coming in here virtually. So I just thought I'd go over a very quick history of HBRC. This doesn't really have anything to do with my talk, but I just thought it would be useful to go over it. HBRC was founded in 1984. Dick Prather was the guy who got it going. Alas, Dick Prather is no longer with us. We ran, the big problem in Silicon Valley is running out of meeting space. So HBRC went moribund during the 90s, and then it got revived a little later in the 90s. We met in the Cupertino library. We were still pretty small then, about 10 or 15 people. And then in the early 2000s, we moved to Castro Middle School. We got a little bigger, okay. We met in the Castro Middle School library. And during that, we started our tabletop challenges, which is our signature of our club, is that we don't do competitions, we do challenges, because we like people to, everybody's a winner when you succeed a challenge, okay? And then eventually we wound up going to the Carnegie Mellon facility over in Moffett Field. That's when I got roped into being president. Okay, and then we moved over to the Google facility, and when I got a little sick, Osmond took over for me, and then we've moved on, and Chris is now, in his first year as being president, okay, and we're doing web for the start. So that's just a quick little history. The tabletop challenge is important, and that's why I've highlighted it, because it's pretty important to how this club operates. Okay, now I'm going to over scroll here. Early on in the club, we were having problems that nobody could build a robot body. So we decided we would do a group purchase of something called the BOBot. This is from Parallax. BOE stands for Board of Education. If you look really closely, And I can see it on my screen. I don't know if you can see it. They have done many, many versions of this. The wheels have gotten better. I think they finally have put encoders of some flavor on. Not great encoders, but good enough. But the one thing they continue to do is they continue to sell the basic stamp. Okay. Anyhow, we did a whole bunch of tabletop challenges using the, oh, I need to make the text here a little bigger. Okay. We bought about 10 of these. And basically we had a lot of fun in the club, and it was really the last time we had a fairly common robot in the club. After that, we more or less went our own ways. Okay. So anyhow, that's the Bobot thing, and it was very useful for getting the tabletop challenges going. In general, the platforms you can buy on the market are pretty much the same. They're 2 motors, some flavor of caster. For a long, long time, we couldn't get encoders. And now more recently, the vendors have figured out that maybe encoders are pretty useful. The processors have been pretty consistently pathetic. Okay, basic stamp, Arduinos, PICs, that's what we had in those days, folks. And so we kind of wound up building our own and trying to make it all work. Okay. Now, the problem with custom robot platforms is there is no commonality. So everybody's is on their own. They have to be their chief engineer, chief support person, everything. Frankly, most of the club members aren't really very good at the mechanical aspects of this stuff. I know I'm not. I keep trying, but it's just not my strength. And then electronics and software sharing, everything's so different. Yeah, everything's kind of a one-off. So it's everybody's got their own unique robot. This is good, but you don't have very much sharing going on. And of course, because they're all one of a kinds, there's reliability tends to suffer. Okay. Now I'm going to zoom forward here to our 2019 FPGA class. That was taught by Brandon Bloget, who's been a member of the club since Castro Middle School, and Patrick Lloyd. And in that we decided, wouldn't it be neat to have a class that taught FPGAs but had a robot? So somebody picked this robot called the Pololu Romi robot. Okay, and it's it's got its wheels, casters, and motors. I'm going to see if I can bring up a video here and see if that works. Yeah, let's see if I can get that full screen. Okay. Oops, what happened here? Sorry. Okay. So that's what the Romeo robot looks like. As you can see, it's just a round robot. It has actually fairly nice casters on it. They're ball casters. It really does have a suspension. And it's quite inexpensive. So for the FPGA class, we went with the Romeo robot. We did a custom PCB for integrating the FPGA to some sonars, LEDs, and edge sensors. We had a group build party where we all got together and had some pizza and built all these robots. We built 20 plus. I don't remember the exact number. It was a lot. And then everybody showed up to classes, and everything, all the software ran on the Raspberry Pi. So basically we could run all the FPGA software, everything just ran on it. So we didn't have this problem of everybody having to get the software installed on their laptop with their operating system. We just said, network into the Raspberry Pi. So after the class, we had a retrospective and we said, wouldn't it be neat if? And that's kind of where this homebrew HR2 project is coming from. We're still, I'd say, only about a third of the way through this project. And HR2 stands for Homebrew Robotics Club ROS Robot. Okay, so HRR or HR2. Okay. And so this is going to be a club-sponsored robot. I'm really pushing ROS hard in the club. For those of you who don't know what ROS is, ROS stands for Robot Operating System, and it was developed at Willow Garage. And it's basically it's not technically an operating system, but it's close enough for me. But it's a lot of shareable software for robots, and that's why I think everybody should use it. We decided that the Romy was actually a pretty good platform, so we decided to keep it. Our FPGA class did not support the Romy ARM. We had mechanical interference, so we'd like this new HR2 robot to support the ARM. As you saw, the ARM was pretty cool. That means we can do our ARM bot challenges. And so we decided we're going to keep the Raspberry Pi. We're going to get something a little better than a basic stamp or an Arduino. And of course, we want to continue to support the FPGA class in the future. But the focus won't be on FPGAs. The focus will actually be more on ROS. Okay. And so that's kind of the goal. So I don't think we ever had any of the FPGA robots run any ROS or ROS2, but I'm hopeful that will change in the future. Okay, so some decisions that got made. So this is 100% open architecture. Okay, anybody can do anything to this. Okay, all the design files and everything will be on our repo. MIT license, got to pick one. That's the one I picked. As many open source software development tools as possible. I'm sure there'll be a few things that aren't 100% open source, but as much as possible. We use GitHub, which is technically not free, but it's free enough for me. And if we ever have problems, we'll just switch over to GitLab, which is 100% free. Somewhere in there, we decided that we were going to go with a daughter board architecture so that we could sort of change things up over time, so you didn't have to throw away the entire board every time. So, for example, we want, the Raspberry Pi has been around for a while. We want to be able to support other than Raspberry Pi single board computers. It'd be nice to be able to support like Jetsons and all of that, but the Romy base just isn't that big. Okay, and I realized I'm just started talking through my slides. Do you have any questions, Arthur?
Nothing yet, just some praise early on for the Parallax products. People seem to like them.
Okay, fine. I need to remember to pause at the end of each slide so that we can do questions. Okay, so we ultimately wound up going with a daughter board architecture. We want to support more than just the Raspberry Pi, but we're still going to be limited by space. Ultimately, I'll talk about this in a little greater detail. We decided to go with STM Nucleo 144 development boards. These aren't the cheapest development boards out there. It's nothing like the ESP32, which is like really, really cheap. But when you think about it, having a sort of a beefy processor with a lot of pins is kind of worth spending a little extra money on. Okay, so that was kind of where we're going there. And then the interesting thing about the Nucleo is it has a whole bunch of plugs on the top. And so the plan is to plug the FPGA boards onto the top of the Nucleo. So that was our expansion strategy. And then in general, I want to have as much expansion on this as possible. I'll talk a bit about Grove, microbus, and other things a little later. So I'm going to remember to pause if there's any questions. I guess not.
Nothing, nothing yet.
Okay, fine. I'll just keep on going then. Okay, so let's talk a little bit more about the Pololu Romy. Okay, my goodness.
Hey, Wayne.
Yeah.
Wayne?
Yeah.
Okay, so let's talk a little bit more.
Who was that? Was that Camp?
That was Camp and his 2-second latency, I
When you
think.
talk about expansion board, it's Camp.
Was that Camp?
Yes. When you,
Camp and his 2-second latency.
when you talk about expansion boards, you're talking about a Raspberry Pi hat, right?
I'll get into that in much greater detail further on. Okay, Camp. So I guess I'm not doing a good mystery novel here. So I'll get into that. Okay. Okay. So let's do the Pololu Romy. It is really very inexpensive. The list price for the platform is $30. Realistically, you should pay another $3 to get an extra caster. If you want to use their encoders, they're about $12 each for a pair of them, $12 for a pair. They have these things called expansion plates that are about $5. It takes two of them to cover up the entire platform. But for example, the ARM thing, it uses half of an expansion plate. And then the ARM is a little on the pricey side, but it's still pretty inexpensive considering how expensive ARMs tend to still be these days. So the ARM is about $80, and it's an expansion plate, 3 servos, a gripper, and the ARM parts. So that's the cost is really very reasonable. You know, we paid a lot more for our BoBots, and this is frankly a significantly superior platform. Okay, so the downside on the Romy platform, the motors are really very small. So this is just not going to have a lot of payload. We're going to be always fighting the fact that we're probably going to be starting to overdrive our motors as we load this baby down. But we'll see how much we can cram on there before the motors give out. And I honestly don't know where we are on that yet. And so it's about 6.5 inches in diameter. So there's just not a lot of room. This is both good and bad because it forces you to make some decisions. Another thing is the base has a ton of mounting holes. This is really good. Most bases you get out there have no mounting holes, okay? And you got to glue or drill or whatever. This has a bunch of them. The bad thing about them is I had to go find all those holes in the mechanical process. So I'll pause here for any questions.
All good. A quiet group tonight.
Okay, well, that's the way it goes. Okay, so now we're going to go do the mechanical design process. The mechanical design process is the furthest along. The reason for that is I need to know where all the holes are so I can design the printed circuit board so all the holes line up. It's just one of those things. Okay, so the way it's done is as people may or may not know, I've been writing a lot of Python these days since I gave the Python talk last November. Okay, so I'm using OpenSCAD for the actual design and rendering of the model, but it's all, rather than writing in their language, I have a wrapper around the OpenSCAD language written in Python that I can use to do computations and things like that. So I have full access to full math libraries and other stuff. Okay. There's this language program that's been around forever called QCAD, which is basically a DXF shower. And DXF was developed for Autodesk, oh gosh, a long time ago. And the Pololu folks provided a DXF file for the Pololu. So I had to pick all of the dimensions for that platform off of it. And I'm going to be showing you that QCAD model shortly. So you'll sort of respect how much, why it took 14.5 thousand lines of code to figure out where everything was. So then the actual model's in another file called scadmodels.py. You don't care about the names, okay? But I wanted to give you an idea about the level of effort here. You know, this is about 20,000 lines of code just to do the mechanical modeling, and it's far from perfect, okay? So let me come over here, and I'm going to pause for any questions, and
So some praise here, some people liking what you're doing. A question about Python SCAD wrapper, is it on GitHub?
Yeah, everything's on GitHub. Okay, so if you go to the project website, which is on the HB Robotics GitHub thing, it's buried down in there, and you have to go down into the mechanical directory, and it's under the SCAD model subdirectory there, and you'll see it called scad.py. And have at it. Okay, it's not complete. It's complete enough for what I needed to do, but that's what it is. Okay. Any further questions?
No, all good.
Okay, good. So now we're going to do the mechanical stack up. Okay, this is probably the more visually interesting part of this talk. Okay, so we're going to do show QCAD. This is just a quick little script I slammed together that fires off all these programs, so I don't have to screw around too much. Okay, so this is the DXF file that Polulu gave us. And as you can see, there are a lot of holes on this thing. Okay, yes, they do come in a regular pattern, and I use that as much as possible, but boy, and I had to pick off a lot of dimensions, and I would go, let me go zoom in, and let's just pick a random hole here. Let's pick that one. So I would zoom in on that, and then I would literally have to go find, see if I can find it over here. And I'm not sure it's going to give me a, if you see me punching through the index, nope, all right, let's try this one. You see the X and Y values changing. Basically, the little corners going, I had to read those numbers off to find the maximum X, Y, maximum, minimum X, Y. It was a lot of fun. Okay, took a long time. And then the other, for vertical heights, I picked those off of these dimensions. So if I needed to find out how high the motor was, how thick the various things were, that was all done using this display. Okay, so that's enough for QCAD. So I'm glad it was an available tool. Now we're going to show some of the modeling. Okay, so we'll do show. So this is OpenSCAD coming up here. Okay, I hope people can see this okay. If not, please do a shout out to
No, it looks good. Looks
okay.
really nice.
Okay, so this is the basic base of the Romy. Okay, now this is 3 pieces. The dark blue is the actual base. It's a single molded piece. The molds that they used for this were not cheap to develop. Okay, but they did a really good job. The motor holders are in the light pale blue. Okay, and I have not plugged the motors into them in this version yet. And that's deliberate. The model is not perfect. Okay, there's actually a battery compartment underneath, and I didn't bother modeling that. So I just wanted to sort of know where all the holes were. Okay, and then I have mounted on here the spacers that are needed. These 4 spacers are to hold the Raspberry Pi or whatever your single board computer is. So you'll have to fit in it. I'm trying to make for sure that you could go from here to there between the motor mounts for mounting your single board computer. And that's just a little over 3.5 inches. So there's the Raspberry Pi is actually not that wide. So this just gives you almost, not quite a factor of 2 extra width over the Raspberry Pi if you can fit it in there. And that was very deliberate. And then these other holes here are used to mount the master board, which is the board that we're going to put all of our cylinders and stuff on. So I just wanted to let you know what that is. So I'm going to kill out of here. And
Hey, Wayne, so a couple of questions about larger overall tasks that the robot will be able to perform. Maybe you're getting to that.
Oh, that's coming later. Okay.
Okay.
Yeah, yes.
And then some questions about the encoders, odometry.
That's coming.
Got it. Great,
Got
thanks.
it. No problems. Let me show you the Raspberry Pi shoved in there. Okay. So what we have here is I've mounted actually 2 single board computers on there. They're actually ORed together so that the green one is a standard Raspberry Pi form factor. Okay. And then I'm using, there's another one I'm working with that I call the other Pi. It hasn't actually been given a name yet because it hasn't been released. It's a little bigger. And so I just wanted to sort of make for sure that I could deal with different sized boards. Okay. I'm trying to use the standard 4 holes of the Raspberry Pi as the mounting holes. But if you just have to find something that lines up with the holes on this, this plate down here. Okay. So that's the Raspberry Pi. You would only put one of these boards in there, obviously. So now then, let's do the master board. Nope. Okay. So the pale green board is the master board, okay? And as you can see, it's got a pretty funny shape. It's mostly round, and then I've had to chop out some holes for the wheels. I've had to chop out a lot of space for the motors and the motor encoders. There's an area in back here that's chopped out for the random connectors on the end of the Pis and various things, so that they're sitting up there. You see that I put a bunch of sonars on here. I'm kind of a big fan of sonars because they're really cheap, okay? When we first started this stuff, the only sonar that was out there was the Polaroid sonar, and it cost $70, and now we buy them for less than $1. They aren't great, but they are cheap. And then this sort of pale green blue is the connector for the Nucleo. I'll be showing you that shortly. These sort of gold connectors are for the encoders, and I'll be explaining that fairly shortly. There's some things that are going to be moving. There's not enough room for the arm to drop down right now, so I'm going to have to be cutting a slot here in the front and moving this front sonar further back so that we have room for the arm to reach down, go a little closer to the floor. And we're still, it's very likely that the arm will not quite reach the floor when this is all over, just because of various random constraints. But I think we can live with arms that can't touch the floor. Okay, so that's kind of that. This one might have some questions. Let's see, any questions on that one yet?
No, nothing specific, but I think generally very impressed.
Okay, thank you.
Gorgeous, yeah.
Okay, so let me do the next one. Now I'm going to do the encoders. The encoders were a pain in the tush, folks. So
Wayne?
Yeah? Now I'm going to do the encoders. Encoders were a pain in the tush, folks. Yeah?
Yeah, you're saying master board. This is the main board, and then you would put a Raspberry Pi or one of the other boards on as the
yeah, that goes on underneath. Board? Yeah, let me show
expansion board, but
let me show you that again. Yeah, that goes on underneath. Yeah, let me show it. Let me just show you that. And you need to mute yourself because of your 2-second delay, Camp.
So as part of this project, you've got
You
the
need to
master.
mute yourself because of your 2-second delay, Camp. So now let me just show this to you. Okay, if you look down here, you'll see that there's the Raspberry Pi board, and then it's kind of, there's all these sonars and things in the way, but this board plugs, the Raspberry Pi board plugs into the bottom of this master board. Okay, there's actually a little more stuff going on here. If you see this little white board here, that's actually part of the Nucleo, and that I had to cut off a piece of the Nucleo and mount it on the bottom of this board. So I didn't want to get too detailed about what's going on underneath the board, but yeah, everything plugs together. It's a sandwich. Yeah, does that answer your question, Camp? Does that answer your question, Camp?
Well, could it be said then that the master board is like a hat for the Raspberry Pi?
Yes, it is a hat. The way you know it's a hat is because I cut the slots in for the hat. Okay, but the difference is it's a big hat rather than a standard Raspberry Pi shaped hat. Okay,
got it. Thanks.
But the difference is it's a big hat rather than a standard Raspberry Pi.
Yeah, it's like a sombrero.
Hat. You got it. Okay. Okay. So, good question, Camp. Okay, now now I'm going to do the wheel encoders. Pause while it computes the image. Okay, so you'll see those bright red things. Those are the encoders. Now, the big breakthrough that I had was when I realized that I wasn't going to be able to use the Pololu encoders. But then I looked at how simple the Pololu encoders are. There's just basically a magnet and 2 Hall effect transistors and some connectors. So I said, well, look, we'll just do our own encoders. They're not that expensive. So the little brown thing here, that is the magnet, and the Hall effect sensors are sit underneath it. And then we have power to drive the motors, 2 pins. We have power and ground to drive the Hall effect sensors. And then we have the A and B encoder signals coming out. So that's what the 6 pins are. And the way you assemble this robot is you have to mount the master board first, and then you have to mount the motors in, because the motors are soldered, these encoder boards are soldered to the motors, and they have to be plugged in from the top. Okay, you cannot put the motors in first and then put the master board in. So it's got a funny constraint there. These little blue clips you see on the motor, those are clips that can be bent back so you can unplug the motors. Okay, they did a really good job on engineering the plastic for the pull loop. So that's how the encoders work. And I'm expecting to get the standard 1440 of the ticks per revolution that comes with the Pololu stuff. We might be able to get a little higher if we're willing to do some experimentation. But most people who put encoders on their robots get really chintzy and don't give us enough. And that means we don't get very good odometry. And we also don't get very good wheel motor, slow motor measurements. So the Pololu did not make that mistake. Okay, I am going to leave that. Any questions?
Yeah, well, actually, it's funny. You're answering the questions as they show up in the chat. You must be reading
I am not reading them. I am not reading them.
Reading minds is what is going on clearly. One question did come up about potential thermal issues on the Raspberry Pi, considering the mounting location.
To be figured out. Okay, we may have to cut some holes in there so that some heat sinks get through. there's the Raspberry Pi 3, that wouldn't be a problem. The Raspberry Pi 4, all of us want to use it, but there's just issues that have to be dealt with the Raspberry Pi 4. We really like to be able to run, 64-bit ROS, but the Raspberry Pi is really still largely 32-bit. The Raspberry Pi 4 has had thermal problems, so people are having to put heat sinks on them. So do we do a heat sink? Do we do a fan? To be decided. We're going to have to figure that out. That's a really good question. Okay, so now we're going to show the Nucleo. Now, one of the things I want to let you know is I have cut a hole in the middle of this Nucleo so I can see through it. Okay, the real Nucleo is solid end to end. The brick over there is the Ethernet RJ45 connector. I really wanted people to be able to plug RJ45 into this, and I didn't want the cable to run into the wheel. So I didn't draw the wheels in there because it made it too hard to show what was going on. But I needed to leave enough space here so that people could get some kind of right angle RJ45 in there, so that if they wanted to plug it into their Raspberry Pi, over here, one of these connectors is a RJ45 connector for the Raspberry Pi. So they want to talk to the Nucleo, they can talk over Ethernet. You can run a pretty high-end RTOS on one of these things, something up at the NUTX level of RTOS, which has a pretty complete stack on it. Okay. So to make this all work, I had to use longer pins. So if you'll see here, there are the pins that come from the bottom of the Nucleo board that plug into the master board. They have a little air gap between them, and that was because I needed the space. Luckily, these are very inexpensive connectors, so I felt that was an acceptable solution. Okay. The other thing is, you'll notice my connectors have notches cut out of them. Those are just visualization notches to help me sort of see that everything's lining up properly. So if I were to zoom, oops, sorry about that. If I were to zoom in really close on one of these things, you'll see that the pins are lining up. Okay, so the pins line up. Okay, then this little connector you see sticking up here, that's an alignment connector so that you won't get off by one when you plug the Nucleo into the board. Okay, it's really easy on the Pi and other things to be off by one. You turn it on, kaboom, you've just lost your processor. I wanted to avoid that by basically having an alignment pin to force it to be properly inserted. Okay, and I'm almost done with the mechanical here. Any further questions on that?
No, no.
Okay. Good. Okay, now this next one's going to be a little disappointing because I call it the arm, but I don't actually show the arm because I haven't modeled it yet. Pause while it computes. Okay, but that purple platform is the standard platform that the Pololu uses to mount their arm. They mount two servos here, and then the arm reaches over and comes down. It reaches diagonally down, so I have to make for sure there's enough room for the arm not to interfere with the master board. So that's to be done. And in addition, the reason why you see these little things sticking up through them is because I'm probably going to have to move this board up a little. So I decided to just leave the standoffs poking through for the moment. So getting the height just right is going to be a little tricky. The Nucleo board is Arduino compatible. You can plug one Arduino shield on top of it. And that is in fact how we're going to do the FPGA boards, is they will use these top connectors on the Nucleo to be able to talk to everything. Okay, the Arduino is pin limited. That these are two pins wide on each side, so we have way more pins available to us to talk to the whole system. Okay, and what would happen is you would plug the FPGA in, and you would negotiate with the microcontrollers to not use those pins. So that's kind of the whole mechanical stack up. It's been a lot of fun. It's a pretty tremendous 3D jigsaw puzzle. So that's kind of where we are with that. Okay. So now I'm going to talk a bit more about the microcontroller selection and kind of how we got to this thing. I've already told you that it's a Nucleo 144, but let me tell you a little bit more why. First, availability really matters on this stuff. There's a lot of little boards that come and go, and the next thing you know, you just can't buy them. They're just out of production. So pretty much the ARM Holdings has been very successful in licensing their technology to a whole bunch of vendors. This is very good. I don't know if people know, but ARM actually stands for Acorn RISC Machine. It doesn't stand for Advanced RISC Machine. Okay, it was actually done for a BBC computer in England called the Acorn. And the Acorn's long gone, but ARM is still around. Okay, Cortex-M means it's a microcontroller, and it's just basically architected to be used as embedded microcontrollers. The partial list of vendors that support Cortex-M is, Cypress, Infineon, Maxim, Microchip, NXP, ST Micro, TI, Toshiba, and more. There's plenty out there. Huge selection of vendors. I really didn't spend a lot of time doing it. I'm comfortable with the ST products. They have a huge selection of products too, so I didn't feel like there was much to worry about there. They were one of the first people to support the Cortex-M. They have a huge selection and a huge following, so I felt that pretty safe there. The next issue was whether or not we were going to pick a chip and just put it right on the board. And this is where this whole daughter board concept came from. What we've learned over the years is you pick a chip, and the next thing you know, the chip's been end of lifed on you. And so now you got to redo the board. Now, redoing the board isn't horrible, but it's no fun. So we decided that we were going to use development boards for this. And so I looked around, and the Microchip has 3 families of development boards. They're called 32, 64, and 144. Those are roughly the number of pins on the chip, not on the board. The board has more pins than that. The 32 was a non-starter, not enough pins. The 64 was a little more difficult to work through. They're cheaper boards. They're not a lot cheaper. But the real problem with them is they were not very compatible with one another. So if you picked one board and you couldn't mix and match them. Whereas the 144 series is one printed circuit board or rule them all. And Microchip got beat up on all of they kept moving their peripherals around on their pins. And so they got beaten up over that. So if the peripheral's on a pin on one board, it's on the same pin on the other board. Okay, so that's kind of the rule. This means you can really mix and match on these boards. So you can go with a low end one, which is an F4. If you can also go up to an H7, and there, who knows, maybe you're up to G9 or something now. I don't know. There'll be more to come. But I'm pretty confident that they'll keep this pin out. Okay, and that's kind of the goal. The other pro, as I mentioned before, is you can plug an Arduino Shield in. Arduino Shields are kind of, big and bulky, but, there's a lot of them out there. The con on this is I think I'm going to have to cut the ST-Link module off the edge of the board so I don't get wheel interference. don't know yet, but I'm planning on it. The ST-Link is the little board that you plug your USB into that gives you debugging capability on the board. If you don't need debugging, it doesn't matter. You can just cut it off. It doesn't, just use a bootloader. So I'll stop there and take questions.
Nope.
No question.
So quiet, which means everybody's loving it.
Okay, well, I hope they're loving it, or else they all they left.
They're still here. No.
Okay.
Got a full crowd.
Okay, good.
I have a question. I have a question.
Go for it, Camp.
Okay, good. What are the different boards? Go for it, Camp. Are the different boards? You're going to be running different functions on them, kind of like the stream batch stuff that we used to talk about? In other words, you've got a Raspberry Pi as well as the neutrino board. What different functions are going to be running on those different boards, and I guess they're communicating with each other?
Okay, very good question, Camp. The key thing here is you can't really run ROS on the microcontroller. I have to be a little provisoed there. There's this thing called micro ROS which might run on it. Okay, but for the most part, ROS does not run on the microcontroller. The microcontroller controls all the motors, the LEDs, the sonars, all of that stuff, and then you talk to it either over your Ethernet connection or a serial connection. And then you talk to it either over your Ethernet connection or a serial connection.
Well, you could run ROS on the Pi, no?
That's what I said. You run ROS on the Pi. Okay. I'm not hearing anything back, so I think that answered his question. Okay, good.
So these would be peripheral boards too. Probably the master would be running on the Pi.
I think that answered his question. Okay, good. I think I've answered your question. The ROS runs on the Pi, and then all the motor control, encoders, sonars, all of that's done on the microcontroller. And then all the motor control, encoders, sonars, all of that's done on the microcontroller.
Okay, I get it. Thank you.
Okay.
Quick, another question for you, Wayne. Any provision for LiDAR or other types of sensors?
Yeah, that's on the list too. Okay, and I'll mention that a little later in the talk. Okay. Okay. Now, PCB development has really just gotten started. Okay. So one of the key things I wanted to do is use this thing called the STM32 Cube. This is a pin assignment thing. Any of us know who've been doing microcontrollers for a long time have known just like how hard it is to get your blinky LED program to work, because you have to get the clocks right, you have to get everything just right, and then you run around the room screaming because you finally got the LED to blink. The Chi Cube really just sort of takes all of that out. Okay, sorry, the STM32 Cube. I am actually going to very briefly, no, I don't know if I can. Okay, I'm going to switch over to a different screen. It's a technical reason, and I'll come back to this very shortly. Okay, whoops. Now I'm going to share a different screen. Okay. Hang on a moment. Oops. Okay, this should work. Okay, this is the STM32 Cube. Okay, this is a 144 pin chip. Okay, and I like microcontrollers with lots of chips. There are a lot of people screw up and don't get enough pins on their chips, and they suffer for it greatly. If you ever want to talk to the Ubiquity folks, they picked the wrong size chip and they have suffered immensely because of it. The way this thing works, let me zoom in a little, is you can pick a chip, and let's go pick PG5. These are the various things that you can connect to it. You can turn it into a GPIO output, and you just click on it, and the next thing you know, it's an output. Okay. If you don't want to change it back to the reset state, you can do that, and it's a reset state. And so this is how this lets you do all your pin assignments, and then you hit a button and it will generate the code to initialize all of the devices. And that's just a heaven sent, okay? And that means that different people can use different pins for different things without having to, like, you know, become a total wizard on how the peripherals on these chips work. And then when you're all done, you go to this menu, and then you export it with alt functions, and it writes a CSV file out. Okay, CSV stands for common separated values. It's basically a spreadsheet format. Okay, and that's really all I wanted to show about the cube. It also has the ability to generate, you know, frameworks for an RTOS, like free RTOS. So there's lots of goodies in there to make life a little easier for people to write code. I think it's a lot better than the environment that's available on the Arduino IDE. So I don't think we need this anymore, so I'm just going to kill it. Okay, and now I'm going to go back to sharing my previous screen, if I can. Okay, that should be the last screen swap. Okay, so the way PCB development works is you use STM-Cube to do your pin assignments. And then we have a bunch of little helper programs that, when we're all done, generate the schematic symbols that we need in order to use these things. Again, when you have a 144 pin part, the schematic symbol is actually pretty involved. Okay, there is a, let me open this one up. There's a program out there on the net. Oh, there it is, sorry. Called KeyPart or KeyPart. Nobody knows how to pronounce the first two letters of KiCad. Basically lets you construct from a spreadsheet the various different schematic symbols that you need. Okay, and so there's an example, there's another example, and here's some more examples. Okay. And I decided to use KeyPart just because, frankly, the KiCad tools for developing schematic symbols they're still pretty clunky. Mind you, I think KiCad's the winner now for the hobbyist market and printed circuit board design. Okay, so let me. Okay. And then when you're all done, you get to feed it into KiCad. So let me bring up KiCad here. So KiCad has a printed circuit board editor and a schematic editor. So let me go see if I, so this is the top level hierarchical design. I'm a fan of hierarchical design. There are people I know who are not fans of hierarchical design. I happen to work for one of them. Anyhow, I decided to use hierarchical design. That means you have top level subsheets that you show, and then you can dive into a subsheet. So we'll enter this one, and this is the one that has the schematic symbol that was generated from this whole process. The schematic symbol is organized by 16-bit port number. So on the ST parts, they have like ports A through, I think this one goes all the way up to at least H, may go up to I. And then you can see the port letter, the PA0, a name for it, and what peripheral got connected to it. So it's pretty informative. The pin numbers need a little bit of explanation. You cannot have duplicate pin numbers in KiCad, and there's two connectors that we have. There's connector 11 and connector 12. So what I did is all of the connector 11 pins are preceded by 1, 1, and all the connector 12 pins are preceded by 1, 1, 2. And that allows me not to have any pin conflicts. And let's see, I guess it goes all the way up to I. Nope. G is the highest port number. And then, hopefully you're not getting too sick watching me zoom around here. And then you have power and reset and all that stuff. So there's that. So I'm going to get out of the schematic capture. And that's very briefly go into the PC board. Okay. Now I mentioned earlier on that the designing the PC board, getting all the holes to line up is hard. So because KiCad is completely open source file formats, there's a little module in my Python program which basically spits out the outline of the board and feeds it into KiCad and positions all of the mechanical holes. So these larger holes are for the Nucleo board, and the smaller holes are smaller spacers for it all. And that's how it goes. So that's KiCad for you. And that, as I say, that's really just getting started. Okay. I'll kill out of that, kill out of that. And so that's how we're going to do schematic capture and design. The plan on this one is this board's going to be a surface mount board for surface mount parts. The FPGA class, we really focused in on having primarily through hole parts. That was because we're going to do the build with a build party, which worked very well. We had a good time at that build party. Got a bunch of pizza and just had a good time chomping down on it all. But this one's going to be surface mount. We're going to try and get as many of these parts mounted at a printed circuit board assembly house as possible. The initial versions of this the Rev A versions are going to be done using something called a Bantam Tools PC build. Let me open this one up in a new tab. So they have a very small mill. See if I can scroll this. There it is. With a very high-speed spindle that you can do mechanical etching of printed circuit boards on. And you can put a printed circuit board that's 4 inches by 5 inches in there. You can do double-sided. And it'll cut out the outlines of the traces. Let me see if I can get some examples of the traces cut. Yeah, here's one that's, so the bit cut out the traces. They can do very fine traces. So we'll be using that to do our initial prototypes. So we can iterate quick, make mistakes, fix them until we basically have it electrically correct. And then we'll go to the larger format board and get that shipped out because it's too big to be made by this. So so that's what we're going to do with that. The catch on all of this is you don't have vias. So the way you do vias is you have to physically feed a wire through the hole at each via and solder it on both sides. So we can live with that. Okay, so that's the Bantam Tools. And I told you that we're going to ship out. So any questions on that?
Yeah, Rowan was wondering if that's a double-sided.
Double-sided, yeah. Okay. Yeah, it does double-sided, and and the software stack is very good. Really, what you're buying is an okay mill with a very good software package, because that's I tried to do mechanical etching on my Shoreline. Yeah, well, that was back in the early 2000s, and I only succeeded once, and I really concluded that it wasn't going to fly in the long haul. And this thing succeeds pretty much every time. It really works.
Hey, and Mark has a question. How do they do feed throughs? Do they put the wires through?
Yeah, I thought I explained that, but I'll explain again because I must not have been clear. What you do is wherever you have a via, you actually have to feed a wire through and solder on both sides. That should answer the question, I hope.
Thank you.
Okay, good. Okay, now I want to talk a little bit about expansion peripherals. Okay, our plan is to, when we do FPGA boards, is we will just make the FPGA board look like an Arduino Shield, but with double row pins rather than single row pins. So that'll give us pretty much full access to the whole robot. So there's about 65 pins that are available on those connectors, and so we'll focus on using those 65 pins, so that the FPGA has full access to everything that's on, that the microcontroller can access. Okay, so this will allow us to teach the FPGA class again, which we do want to do. Okay, because the Nucleo has a Arduino Shield compatible, I just thought I'd just show the Arduino Shield list. There's a lot of them, folks. Most of these are not available, okay? They've sort of gone, they made a bunch of them and then they kind of went away. But there's a few people that made a bunch of them. Okay, there's Adafruit, has 9. Let's see, Seed Studio has 14, and I think Spark Labs is the winner. Or Spark Fun. Spark Fun has 26 of them. Okay, so so there's a bunch of them available, but they're kind of big, and they don't really. They try and show them stacking very well, but anybody who's tried to stack an Arduino Shield knows they don't stack very well because you have pin assignment problems. So now I'm going to show you another one, which I really like. Oops. Okay. This is the Seed Studio Grove, and let's make this a little bigger. Okay. They have this kind of weird shaped board. Those holes are on 10mm centers. Okay. And basically, they have a lot of boards available. Okay. Let me go make this just a teeny bit smaller. Okay. So they have, various button boards, communication boards, display boards. They actually have an OLED board on here. It's probably here in the back. Okay, so you see that. They have quite a few sensor boards, ton of just standard LED boards. And so there's probably over 100 boards that you can plug into this. It is a 4-wire connector. It's it's a shrouded connector, so you can't plug it in back. Shrouded and keyed connector, so you can't plug it in backwards. And basically, you can either talk I2C or there's a few of them that are SPI and some of them are RS-232. So you have some flexibility there on what protocols you can talk to them on. But I wanted to, I get tired of everybody not having sort of a standard bucket of parts that to use on their robot. And this provides it. But wait, there's more. Okay. Now I'm going to show you yet another family. Okay, these boards are just a teeny bit bigger. And the boards are called click boards, but the standard is called microbus. Okay. So microbus is a 20-pin standard. and it's got RS, serial, I squared C, SPI, and it's got 3.3 volts, 5 volts. It's got, a few other, it's got all the stuff you would expect. And then there's a lot of boards, okay. So I'm not going to go through all of these. There's wireless boards, sensors. Oops. Clicked the wrong place, sorry. Yeah. Anyhow, you get the idea. There's like over 100 of these too. They tend to cost more than the Grove Studio boards, but you have more flexibility with these boards in general. So again, I want to put a few of those connectors on here as well. Okay, let's do this. Okay, one of the problems with the Raspberry Pi is they really only have one good serial port on there, and everybody wants to use it. So there's some engineering that has to be done here to figure out how to share that serial port. I've got some ideas, but that hasn't been nailed down yet. And then people asked about LiDAR. Yeah, I want to be able to pop a LiDAR on here. How can you do ROS without a LiDAR, really? You can, but a LiDAR would be nice. LiDAR will probably cost almost as much as the robot. The cheapest LiDAR I have found is the Y-LiDAR X2 for $70. I have no idea how good it is, but there's a whole bunch of them in that price range of $70 to about $140. And in addition, if you can sweet talk somebody into giving you a used Nito one, we'll be able to support the Nitos as well, I hope. So yes, we want to support LiDARs. Okay. So that's the expansion strategy. And now we're almost at the end of this. Yes, we want to support LiDARs.
There's another one out there by Hitachi.
So that's the expansion. Thank you, Camp. Again, we don't. I'm not going to pick them. What I'm going to do is let other people pick them. But
there's another LiDAR out.
Camp. Again. Okay, I think I'm going to move on here. Okay, now the software hasn't really been started yet. I'm using Ubuntu 18.04 for all development right now. I generally wait 6 months before I switch between LTS support. So when 2004, when 2010 comes out, I will switch to 2004. So that'll probably occur sometime in October. I've got an installation script, which is largely done. And we've got a bunch of the software for using the ST32Cube IDE. That's an Eclipse plus some STM stuff. No ROS 1 or ROS 2 stuff has been started, but I'm not really expecting too much problems with that until we try and mount ROS 2 on a Raspberry Pi 4, because I think we're going to have problems with that. So no drivers have been written. We want to support simulators. Okay, so this is the part of this project that is like, it's probably the biggest part, and it's going to take a long time to go. We're going to want to have a bunch of courses. Okay, obviously we want to be able to do all the tabletop challenges. We want to give the FPGA class again. So maybe I can teach my KiCad class again, ROS classes, etc. I should pause again. I keep forgetting to pause. Any questions?
No questions right now. Just I think generally everybody's pretty excited. This looks really, really cool.
Okay,
really
thank you.
Well done.
Thank you. Okay, so let me just talk about the schedule. Okay, the schedule is we want to have the Bantam Labs board done by the end of June. Okay. I'm actually saying we here because I'm actually expecting to get some help on that. Not a ton. It's very hard to do parallel development on printed circuit boards. I've done it before, actually with Rohan. Okay, we did Loki together. But only one person gets to actually edit the printed circuit board at a time. But the schematics you can actually do concurrent development on, because you can say you'll get to work on this schematic, and because they're kept in separate files. Okay, Rev B is end of August is what we're going to shoot for, and I think I've got somebody who's willing to pay for the first batch of boards. Okay, so because we'll almost certainly make some mistakes on that, and then ultimately what we're shooting for is to have a working robot by the final meeting of this year, and that would be November 19th. Remember, Thanksgiving is too close to our meeting this year, so we're going to be meeting one week earlier. So that's why it's November 19th. And then if we want to do a BOBUT level group buy, the time to do it is actually during Black Friday through Cyber Monday, because Pololu historically puts their stuff on very good discount. So when I bought my ARM on Cyber Monday, it was $40, not $80. Okay, and they generally tend to cut their prices almost in half. So if we want to do a group buy, we can do that. My ultimate goal on all of this is that there's enough commonality in this platform to get a little more sharing going on. That's ultimately what I want to do. I'd like it to be the case eventually that a new person walks into the club and says, where do I start? And we say, here, buy this robot. We have a few extras here. If you like it, keep it. If you don't like it, sell it back to us, and we'll sell it to somebody else. That way people don't get stuck in this of how do I build my robot? They can just get going and actually start trying to program their robot, because a lot of people just want to program the things. Okay, so conclusions. Definitely a work in progress. I've got 6 months to try and hit my schedule. We'll see if I make it. I'm very open to help. Okay, so if you go to this GitHub site and go, this is based off the HB Robotics GitHub repository, and go to the HBRC ROS Robot platform. That's us. There's a Google Groups set up for it, and I am going to open it up for questions.
So I think at this point, if folks have a question, why don't you go ahead and unmute yourself and ask, and we'll see if it
turns into chaos. Yeah.
Yeah.
Will boards be available for sale?
I don't know. I don't have a good answer for that. I would suspect that Pololu would be pretty interested in this board. Okay, they are.
No, I
selling.
mean, if I wanted to participate in this, do I go and take KeyCAD and send it to GLC?
Oh no. We do a group buy. Group buy.
Beautiful.
Yeah. No. There's no reason not to do a group buy. And then I would actually like it if Pololu got talked into just stocking the parts so that we don't have to deal with doing group buys. So that's the plan. Next question. Ooh, silence. Tough crowd.
Well, we do have one in the chat asking about. I think you covered it about the challenges that the robots will do. That you're really set up to do most of the challenges that the club has already designed.
The goal is to hit pretty much every challenge we do. Floorbot challenges, ARM challenges, tabletop challenges. We want to be able to do them all with a single platform. And then in addition, I believe we're eventually going to start having ROS challenges, like here, bring ROS up, and can you steer your robot? Can you run a ROS robot on the table without falling off, kind of thing? You get the idea, and just work our way up.
Wayne, do you have an opinion yet? ROS 1 versus ROS 2 for this? Or?
Oh, ROS 1 versus ROS 2. That's a topic. Okay. And ROS 2 is a work in progress, folks. And that being said, we're amateurs. We're supposed to take, take risks. If I were doing a product right now that I wanted to sell, I would not touch ROS 2 yet, because I just don't think it's quite ready. I'm really hesitant to say that, but it just doesn't feel quite ready yet. But if you're a hobbyist, yeah, we should be dabbling in it. Okay, we've already got a bunch of people that have tried to use it. I'd kind of like it to be, this time next year, most of the club is running on ROS 2, but that may be just a little bit too optimistic. I just don't know. There may not be enough drivers ready for various parts. We'll see. That's a tough question, and it's, one of the talks I want to bring in is I want to bring Tully in and have him do a ROS 2 talk so that he can make the pitch. It shouldn't be that hard to get him.
Hey, Wayne,
Yeah.
mind if I chime in on this topic?
Yeah, sure. Who's speaking?
Rohan.
Okay. Hi, Ron. Yeah.
Yeah. So there's a few different challenges with ROS 2. One is, yes, there is not enough driver support. A lot of things have not been ported over. Obviously, there's the ROS 1 to ROS 2 bridge, but that's a little bit easier to use now. But that's kind of an interim solution, and ideally, you would want to run native ROS 2 for everything. And the other main challenge is getting it running on a Pi reliably. I don't know if this has changed with Foxy, which is the upcoming ROS 2 release, but OSRF has not been doing 32-bit ARM builds, which means that we will need to run 64-bit operating system on the Pi. And that is something that the Raspberry Pi Foundation has not been supporting thus far. So that's kind of the mix of issues that we're dealing with. It seems like the Raspbian kernel now supports booting into 64-bit mode. None of the user space stuff is working yet, but it seems more likely that we will have 64-bit support, even if it's not built into Raspbian, but support on the underlying libraries to make it work under Ubuntu. And then we can run 64-bit operating system, which would be great.
Yeah. And I want to add here that there are other single board computers out there that have taken the plunge to 64-bit only. So it may be that we might have to sort of say, if you want to run ROS 2, you might for a little while you might have to run something other than a Raspberry Pi 2, Raspberry Pi.
Yeah, a lot of the single board computers that are coming out today are 64-bit. So for some of the people in the chat, the Raspberry Pi 3 and 4 are 64-bit, but they are booted into 32-bit mode when you're running Raspbian. There is some underlying kernel and userland support that's needed to get things like camera working for a lot. Like if you want to use the Raspberry Pi camera, that is something that's difficult to get running in 64-bit right now. It is getting better. I've seen a lot of people get it working. It's just something that's kind of hacky right now that hopefully will get better. And maybe when we get around to we being the Ubiquity Robotics image gets around to jumping to 2004, we can also implement 64-bit at that time.
Yeah. So anyhow, that's a tough, gnarly question, and well, I think ROS 2 is where that's where open robotics is headed. So I think you need to follow the leader here, but it's gonna be a rough patch there, because the 1 to 2 transitions are always the hardest transitions. So Okay, so I'll just make one final pitch. If any of you are excited about this, please join the little Google, visit the repo here and go read the README and join the Google group. And if you feel like pitching in, there'll be a little bit more chat going on that group soon as things start to happen. And but if not, I'll just keep on chugging away at this because this is kind of a it's been a pet project of mine for a long time to have a robot that people can just buy and use and get going. Okay. I kind of it's been a pet project of mine for a long time to have a robot that people can just buy and use and get going. Okay. Thank you.
That's Camp's delayed applause for you.
Okay.
So well done. Lots of cheers in the chat for you.
Okay.
Wayne, well done. Thank you.
Okay, I'm going to stop sharing my screen and then now maybe I can read the chat. Okay, so I'm going to stop the share. Okay.
All right. Thank you, Wayne, and thank you, everybody else. That pretty much concludes the meeting. I want to remind everybody, please give some feedback as to what went well and what we can do better for next month's meeting. I think we'll continue to leave the mics on for people to banter about. We'll leave the chat channel up for at least until Arthur is tired of monitoring it. Again, thank you, Wayne. Thank you, Arthur. And thank you to everybody who participated.
Okay.
Yeah, so we can, Chris, do you want to leave? We can leave this open if people want to try to talk. We can see if we have a disaster, or we can close it down.
Give it a try.
Thank you so much. It was nice being a part of my
Hey. Hello, Nigeria.
Yeah, well, fine. I'm happy to connect with you guys. I hope to learn something that will make me start my robotics school here in Africa.
What time is it over there right now?
It's about 5:40 a.m.
Oh, wow.
Wow. You're dedicated to be here.
Sure, there's no power. I have to use a small touch to see. I have to use my laptop. It's not easy over here. I have to use a small touch to see. It's not easy over here. It's not easy over here.
That's
But
dedication.
I want to see that my people are carried along. That's my desire. I want to see that there's great things that are happening here. The people of Africa are part of it. So my friend John Sokol advised me to be part of this Zoom meeting.
Well, that's fantastic. We're glad to have you, and let us know how we can help you.
Yes, I want to start up a robotics school. I have some kids in cities close in Lagos that are also trying to do drones and robots, but they are too poor to organize themselves. They barely could speak English well. They don't have a laptop. They don't have devices. So I got some funding from my friend in America. We've gotten a bigger hub. We are currently refurbishing the hub. So what I want from you guys is a situation whereby some of these used kits you are not using, you can send them over to ROS, and also we can do some Skype training for them because these kits are too poor. They cannot pay for fuel to run and charge their phones and laptop. They cannot buy data, and they don't even have a good laptop. But because of the help I got from my friend in America, I'm able to rent a bigger space. And for some time now, I'll be able to give them power supply and also give them data. So what I want from you guys is some of these kits you are not using, if you can ship them down to me, and then if there are some used laptops, then online tutorials, that's fine by me. I don't need cash.
So what, maybe one thing to think about, and Chris, that our president can respond, but is as Wayne's new platform becomes available, we'll see what that looks like, and maybe we can learn a little bit more about you and the organization you want to set up. I think that would be useful to understand more about.
Yes,
what you're doing.
We've already started some things before, but now we're going bigger. We got a bigger space. We are actually refurbishing. Hopefully in the next 2 weeks, the space will be fully ready. He sent me some funds, which I'm working with. So what I just want is, when we start, if we could get some Lego kits, some of these devices, 3D printers, if it's on a personal or whatever, just a little, let's gather ourselves. Then I'll try to bring the boy from Lagos to Warri, which is about 8 hours drive on a good day. And then I'll augment some of his feeding and also be training him on chemistry, physics, and some other stuff, because he needs to go to university also. John is aware of him, and I sent him a few dollars, about $20 just last week, to try to fix his laptop. But the fact still remains that he's using old, outdated tools, and our people don't have tools to work with. So what we want are really tools, and then tutorials. For now, someone has been so kind and given us some cash. So we are not asking for cash now. We just
All right,
want
Alvin,
tools.
thank you for mentioning the school. I did notice that he did start a thread on the news group. So
Yeah.
we'll move this discussion over to the news group. I want to keep tonight's meeting focused on robotics topics. So thank you. And if you want more information on this school, please go to the news group.
Okay, thank you.
Well, I guess that's it. There doesn't seem to be a lot of banter going on, so.
Well, thank you for letting me join from Maine here.
Yeah, we've got a visitor from China too, Andrew Hong.
Oh wow.
Is that so? Is this
Who's one of
Bunny?
my colleagues
Andrew
at
Bunny
NICO.
Bunny?
Yeah, I mean, I'm joining from Canada. Is there any?
Andrew Huang.
I mean, I'm joining from Canada.
And I see
Yeah,
Walter
is
from
there any way
LA.
to get this to continue after the COVID-19? You know, I've been wanting to join one of your meetings for quite a while, but coming down from here is a bit of an investment for a one-night meeting.
Yeah, it would be great if there was some kind of, someone put it in the
This is
chat,
actually well
a
suited for
Zoom
robotics.
seat, a Zoom seat in the real meeting, especially for those of us who go away to college for 9 of the 11 meetings.
We have a couple of.
Go ahead.
We have a couple of options for that. It's normally when the meetings are held in person at rooms at Google, we can use Google Meet, and I think the officers of the club have been talking about that. There's also live streaming to YouTube, which is also an option out of the rooms that Google provides us. So using Google products obviously is what those rooms support. So Google Meet or YouTube live streaming are possibilities and something we may talk about.
Yeah, back in the days, this is Wayne. Back in the days, we actually were very briefly video
How's the weather in
broadcast.
Indiana, Rohan?
We were actually doing some video broadcasting back in the early 2010s kind of time frame, but it didn't work. The technology wasn't there yet, so we stopped.
Yeah, I think back then it was Ryan Hickman trying to hold a tablet up and walking around the meeting trying to broadcast it. But if it's built into the rooms, then hooking into Google Meet is probably going to be much easier.
Yeah, I'd give it a shot. It's what I've wanted to do for a long time because, I mean, that's why we've been videoing the meetings for so long is because we knew
That's
that.
been great.
Yeah, yeah.
Yeah.
The
Here
room
in
that
Maine, I
we're
can
in,
see all those. Those are wonderful. There's like I remember from Anki, you had some people, and it was great. The YouTube videos. Thank you.
yeah, the room we're in now at Google is a full production video, multi-camera video production system. So it's just a matter of getting it set up and actually doing it. But we have the very sophisticated capability in the space that we're in now.
Well, I have a meetup here in Maine, and we have about 3 or 4 people that get together about once a month, and I kind of pass on some of the stuff that you guys do, like the telepresence robots that were playing soccer. That was so cool. But thank you very much. Oh, and Wayne, your work has been top notch. Did you make the little green robot, the Scoot bot, I think?
No, I did not.
Oh, okay. There was a little. Okay, sorry.
Yeah, I've made lots of robots over the years, but not that one.
Yeah. Okay. Thank you.
All right, shall we call it a night? I think.
Sounds like it's a wrap, folks. So let's try again next week, month, and constructive criticism on the group.
Try again next week, month, and constructive criticism on the group.
Fine.
All right, good night, everybody. We'll shut it down.
Okay, bye-bye.